Hello everyone, this is Dr. Fan. Newton's laws are the foundations for classical mechanics, and today let's discuss Newton's first law, and let's see if you really understand Newton's first law. Alright, let's first see what Newton's first law says. So the law says a body at rest will remain at rest, or if in motion, remains in motion at a constant velocity unless acted on by a net external force. So the keywords are under no net external force, there is no change of motion. So maybe in the beginning the object is at rest, then the object wants to remain at rest, or maybe the object is moving, it wants to remain in motion with constant velocity, unless a net external force applies on to the object. So this is clearly a body wants to maintain its motion. So that's why Newton's first law is also called the law of inertia. And the larger the mass, the larger the inertia. So the keywords here are under no net external force, there is no change of motion. Alright, the statement in the law is very straightforward. Now let's put your understanding into a test. So let's first look at this question. An object is moving with constant velocity. Which of the following statement is correct? So the choice A says there must be an even number of forces canceling each other. So if there's a force on this side, which is F, there's a force on this side, which is also F. If they cancel each other, the net external force is 0, then it's possible that the object is moving with constant velocity. But this is only one situation. You don't have to have even number of forces. For example, I can apply force of 2F on this side and the other two forces on the left side. In this case, my net external force is still 0, so the object may be under 3 forces and moving with constant velocity. So this choice is wrong. The second choice says there may be only one force on the object. So if there's only one force, then the net external force equals to that force. And this clearly does not equal to 0. So that means the object has a net external force. So the object cannot move with constant velocity. So this is also wrong. So the third option says there must be forces on the object. The Newton's first law says if an object is moving with constant velocity, then the net external force is 0. But there is a possibility, that is, there may be no forces on the object. Under that situation, the net force is still 0, so the object could be moving with constant velocity. So this choice is wrong. Now let's look at the fourth option. It says adding forces will change the motion of the object. If I add a force F to the right, add another force F to the left, they will cancel each other. So the net external force is still 0, so my object can still move with constant velocity. So this is also wrong. The last option says whether there are forces on the object or not is unclear. This is the correct choice. Because an object moving with constant velocity, we just know the net external force is 0. Maybe there is force and they balance each other, they cancel out each other, or maybe there is no force at all. Alright, let's look at another practice problem. So let's say a ball is placed on a frictionless wood block. Initially, they are at rest. If the block is suddenly pulled away, what happens to the motion of the ball? Let's look at what happened before and after we pull the block away. So before we pull the block, the ball and the block are both at rest. After we pull the block out, along the horizontal direction for the ball, the net external force is 0. So in other words, for the ball, the net external force along x direction is 0. Based on Newton's first law, if the net external force along x direction is 0, so the motion along x direction should have no change. And we know before we pull the block out, the ball is at rest along horizontal direction. So afterwards, the ball should also be at rest along horizontal direction. So at rest along horizontal direction. Now let's look at the y direction. If we pull the block out, there is gravity on the ball. So the net external force along y direction is not zero. That means the motion along y direction is going to change. And what's going to be the change? We know the ball is going to fall. So overall, we know what will happen to the motion of the ball. That is, after we pull the block out, the ball is going to experiencing free fall. And along horizontal direction, there is no motion. Horizontally, it's still at rest because the net external force along horizontal direction is zero. Now let's look at another very interesting question. So the question says, a spring is fixed on a moving car, and the spring is being compressed by a ball on top of it. So this is the ball. And at a certain moment, the ball is launched vertically from the spring. Where would the ball land? The velocity of the car does not change before and after launching, and we assume there is no friction or air resistance. So this question might give us different choices. The ball may land in front of the car, may land behind the car, or may land right on the spring. Let's evaluate the situation. So before launching, the ball is moving along with the car. So the ball should have a horizontal velocity of v. And while you want to launch the ball acquires a vertical velocity. So think about what happens along the horizontal direction. After the ball is being launched horizontally along x direction, there is no net external force along x direction. So the motion along x direction should not change. That means before and after launch, the ball along x direction should move with constant velocity v. And vertically, because during launching the ball has a vertical velocity. So basically the ball is going to have a trajectory of a projectile motion. Alright, now let's answer this question directly. Where would the ball land? Is it going to hit right into the spring, or behind, or in front of it? Because we know before and after launching, the ball would have a constant velocity along x direction. And we also know the car does not change its velocity before and after launching. So that means both the ball and the car has the same horizontal velocity. As a result, the ball is going to hit exactly the spring because they have the same horizontal velocity, they have the same horizontal displacement. So the ball is going to hit here. This is very similar to the classical question about a plane dropping a bomb. So for example, if we say a plane moving with constant velocity dropped a bomb, where would the bomb land? So before the plane dropped the bomb, the plane and the bomb, they have the same horizontal velocity. If we assume there is no friction air resistance, after the bomb is being dropped, the bomb is going to experience free fall along the vertical direction, but horizontally, its velocity v will not change. So that means both the bomb and the plane moves with the same horizontal velocity. As a result, the bomb is always going to be directly under the plane because they have the same horizontal velocity. The situation will change if a plane is accelerating. Let's look at the similar but a different question. So let's see if a plane accelerating with a constant acceleration and the plane dropped a bomb. Where would the bomb land? Alright, let's see while the plane dropped the bomb, the plane and the bomb has a velocity of v. Based on Newton's first law, after the bomb is being dropped along the horizontal direction for the bomb, sigma f net x is 0. So for the bomb, its horizontal velocity will not change. So the bomb moves with constant velocity, v. But we know the plane is accelerating. So that means the plane's velocity is gonna become larger and larger. As a result, when the bomb lands on the ground, the plane would be ahead of the bomb because after the plane dropped the bomb, the plane is always accelerating, but the bomb moves with constant velocity. As a result, the plane is ahead of the bomb. Alright, let's summarize what we have discussed today. So, the key thing about Newton's first law is under no net external force, there is no change of motion. And you do not need a force to keep an object moving. So for example, if an object moves with constant velocity, the force may be zero. Maybe there is no force at all. And in real applications, sometimes it's very important to pay attention along the x or y direction. For example, if there is no net external force along x direction, that means there is no change of motion along x direction. Similarly, if there is no net external force along y direction, then there is no change of motion along y direction. Hopefully today's discussion about Newton's first law help you to understand this law better. Thank you very much. I will see you next time.